Hello there, and welcome to the Dreamy Ocean Channel. As the gentle currents of evening begin to pull you into their embrace, allow your breath to deepen, feeling the subtle rise and fall within your chest. Release the tension from your shoulders, let your jaw soften, and simply exist within this quiet moment. Now imagine yourself floating effortlessly upon the surface of a vast, tranquil ocean, beneath a sky dusted with distant stars. The cool, quiet water cradles you, and below, an immense silent world stretches into unfathomable depths, holding mysteries whispered only by the slow, deliberate currents. Within these profound and ancient waters resides a creature of extraordinary paradox, a small being capable of leaving its indelible, perfectly circular mark on the largest inhabitants of the deep, a silent surgeon of the abyssal realm. Let your mind drift gently into these waters as we begin to explore the enigmatic life of the Cookiecutter shark. An introduction to Isistius brasiliensis. The vast, encompassing darkness of the deep ocean holds within its chilled embrace countless forms of life, many still awaiting the gentle beam of human curiosity. It was within this boundless watery realm during the early decades of the 19th century that the first whispers of a truly singular creature began to surface. A time when grand sailing expeditions charting distant coastlines and unknown currents also served as nascent probes into the mysteries of the marine world. On one such voyage, the French corvettes Uranie and Physicienne, under the command of Louis de Freycinet, traversed the expansive blue, their scientific crew meticulously collecting specimens from the unfamiliar waters they encountered. Amidst the myriad of strange and wonderful beings drawn from the depths by the rudimentary nets of the era, a small, elongated fish emerged unlike any seen before. It was in the year 1824 that two naturalists aboard these ships, Jean-René Constant Coy and Joseph-Paul Gaimard, carefully examined this peculiar specimen. Its form, though small, held a silent promise of an entirely new understanding of predation in the ocean's twilight zones. They noted its slender, almost cigar-shaped body, reaching perhaps the length of a human forearm, its skin a muted, almost uniform, dark brown, blending seamlessly with the perpetual dusk of its natural habitat. This discovery, retrieved from the waters off Brazil, became the very first formal introduction of Isistius brasiliensis to the annals of scientific knowledge. The name itself, Isistius brasiliensis, holds a quiet poetry, a reflection of both its origins and its enigmatic nature. The specific epithet, brasiliensis, anchors its initial identification to the geographic coordinates of its discovery, a small, almost incidental detail in the grand history of ocean exploration. But it is the generic name Isistius that whispers of deeper meanings. It is believed to be derived in part from Isis, the ancient Egyptian goddess, a deity associated with magic nature and the subtle, unseen forces that shape the world. This naming choice perhaps intuitively acknowledged the creature's mysterious presence, its ability to operate with a kind of ethereal precision, leaving its mark without being widely observed. It hinted at a hidden power, a quiet, almost magical efficacy in its actions long before its full predatory prowess was understood. For many decades following its initial classification, this small shark remained largely a curiosity, a preserved specimen in jars and entry in taxonomic ledgers. Its true significance, the astonishing uniqueness of its feeding strategy, remained obscured, a secret held tightly by the vast, unyielding ocean itself. It was simply another one of the countless fishes that populated the deep, its existence acknowledged, yet its profound impact on the marine ecosystem utterly unappreciated. The very notion that such a diminutive creature could engage in a form of parasitic predation on animals many hundreds, even thousands of times its own size was simply beyond the prevailing scientific imagination of the time. The ocean, in its infinite wisdom, was slowly, patiently preparing to reveal one of its most peculiar and unsettling truths. The early 20th century began to bring forth curious anomalies from the deep observations that would much later converge upon the Isistius brasiliensis. Fishermen, whalers, and increasingly marine biologists began to report strange, perfectly circular wounds upon the bodies of large marine animals. These were not the ragged, tearing injuries left by larger predators, nor the irregular abrasions of environmental hazards. Instead, they were astonishingly precise, clean-edged excavations, as if a specialized, perfectly round cutting tool had been pressed against the flesh and then withdrawn. Imagine for a moment the smooth, almost surgical precision of these wounds, a stark contrast to the chaotic struggle of life and death in the wild ocean. These mysterious circular lesions appeared on the sleek grey flanks of whales, on the powerful bodies of dolphins, on the robust forms of tuna, and even on the tough, leathery skin of seals. They were found on fish of various species, sometimes multiple bites, scarring a single individual, each one a testament to an unseen, meticulous attacker. For a long period, the source of these enigmatic wounds remained an unsolved puzzle, a silent riddle etched onto the living canvas of the ocean's giants. Various theories were put forth, each attempting to explain the inexplicable. Some hypothesized that deep-sea lampreys with their rasping mouths might be responsible, yet their feeding marks seldom exhibited such perfect geometric symmetry. Others considered the possibility of unknown deep-sea parasites larger than any previously documented, or even some form of environmental abrasion, though the consistency of the circular shape defied such explanations. The sheer uniformity of the bites was the most perplexing aspect. Each wound, regardless of the victim's size or species, presented a remarkably consistent diameter, typically ranging from about 2 to 7 centimeters across. The depth of the tissue removed was also strikingly similar, always reaching into the muscle layer, leaving a scooped-out crater of flesh. It was as if a single standardized instrument was being applied across the entire ocean, leaving its unmistakable signature. This persistent, unsettling pattern spoke not of random chance, but of a highly specialized, deliberate, biological mechanism. It was not until the mid-20th century, as deep-sea exploration advanced, with more sophisticated equipment and direct observation became marginally more feasible, that the pieces of this profound puzzle slowly began to coalesce. The small, cigar-shaped shark, Isistius brasiliensis, which had languished in relative obscurity for over a century, was finally identified as the perpetrator of these peculiar scars. The realization dawned that this unassuming, relatively tiny predator possessed a set of anatomical adaptations that allowed it to execute such a unique and startling feeding strategy. The revelation transformed the Isistius brasiliensis from a mere footnote in ichthyology to one of the ocean's most fascinating and unsettling characters. It acquired the common name by which it is now widely known, the Cookiecutter Shark. This evocative moniker derived from the domestic tool used to cut dough into perfect shapes, perfectly encapsulated the visual evidence of its predatory style. The name, though seemingly whimsical, belied the stark reality of its actions. A creature so small, yet so perfectly equipped to carve a clean, precise, and often deep wound from the living flesh of far larger beings. This initial understanding of the cookie-cutter shark unveiled a creature existing at the very edge of our comprehension, a deep-sea anomaly that challenged conventional notions of predator-prey relationships. Its small stature, rarely exceeding 50 centimeters in total length, stands in stark contrast to the colossal dimensions of its preferred prey, which can include the largest whales in the ocean. This disproportionate interaction forces us to reconsider the subtle, yet potent forces at play within the marine food web. It is a world where size does not always dictate dominance, and where specialized adaptations can grant even the smallest inhabitants an extraordinary power. The cookie-cutter shark's existence is a testament to the boundless ingenuity of evolution, a slow, patient sculptor of life forms, forever refining and adapting them to fill every conceivable ecological niche. It inhabits the vast, largely unexplored pelagic zone, the open ocean far from the coasts, spending its days in the perpetual gloom of the mesopelagic and bathypelagic depths, hundreds to thousands of meters below the sunlit surface. Here, light barely penetrates, if at all, and the water pressure is immense, a crushing force that few terrestrial creatures could ever withstand. It is a world of silent drifting, of slow, deliberate movements where encounters are rare, and every advantage is critical for survival. This deep-sea environment, with its scarcity of food and its overwhelming darkness, has shaped the cookie-cutter shark into a master of opportunistic parasitism. It does not hunt in the conventional sense, chasing down prey in a high-speed pursuit. Instead, it employs a strategy of stealth deception and precise surgical strikes, a method that conserves energy in an environment where every calorie counts. Its entire being, from its unique dentition to its specialized musculature, and even its subtle bioluminescent patterns, is meticulously engineered for this singular purpose: to approach an unsuspecting host, take a perfect bite, and then retreat back into the boundless anonymity of the deep. The initial identification of the cookie-cutter shark as the source of these mysterious wounds was a pivotal moment in marine biology. It illuminated a previously unknown facet of deep-sea ecology, revealing a parasitic relationship of astonishing efficiency and precision. This small shark, a creature that could fit comfortably in a human hand, had been silently, almost invisibly influencing the health and behavior of countless larger marine animals for untold millennia. Its bites, once a bewildering enigma, now became a signature, a calling card of a deep-sea surgeon operating with an unseen scalpel. As we begin to peel back the layers of mystery surrounding Isistius brasiliensis, we are invited into a world where the familiar rules of the surface ocean often do not apply. We are delving into an environment where light is a precious commodity, where sound travels with startling clarity, and where life forms have evolved truly extraordinary methods to survive and thrive. The cookie-cutter shark, in its quiet, persistent way, stands as a profound symbol of this alien world, a creature whose very existence challenges our preconceived notions of what is possible beneath the waves. Its story is not just about a shark, but about the enduring power of adaptation, the relentless pursuit of survival, and the endless wonders that still await discovery in the deep, dreaming ocean. Its introduction to science was merely the first tentative step into understanding a predator that operates more like a ghost than a hunter, leaving behind only the perfect circular echo of its passage. The cookie-cutter's peculiar form, the quiet revelation of the cookie-cutter shark's existence, and the profound mystery of its circular scars beckons us now to explore its physical form, to understand the meticulous design that allows such a small creature to wield such disproportionate power. To truly appreciate this deep-sea denizen, we must observe it as if through the slow, drifting gaze of the ocean itself, tracing the contours of its body, sensing the subtle adaptations that define its life as an anatomical shadow. Its overall silhouette is one of understated efficiency, a streamlined torpedo shape often described as fusiform or cigar-shaped. This elegant, elongated form, tapering gently towards both the head and the tail, speaks of minimal resistance as it glides through the dense cold water. An adult cookiecutter shark. Isistius brasiliensis typically measures no more than 50 centimeters in length, sometimes reaching 60 centimeters in size, that might fit comfortably within the span of a human forearm. This diminutive stature, when contrasted with the colossal whales and large pelagic fish it targets, is perhaps its most striking paradox, a testament to the evolutionary power of specialized adaptation over sheer size. The coloration of its skin is equally subtle, a muted palette perfectly suited for its life in the abyssal gloom. Its dorsal or upper surface typically presents a uniform, dark brown or grayish-brown hue, a shade that would blend seamlessly into the perpetual twilight of the mesopelagic zone, where the last vestiges of sunlight struggle to penetrate. This dark upper surface transitions into a slightly paler ventral, or undersurface, a form of countershading that paradoxically might not function in the traditional sense where light comes from above. In the deep, where ambient light is scarce or absent, this coloration may instead serve to absorb any stray photons, rendering its silhouette less discernible against the varying backgrounds of the deep. Moving towards the head, we observe a short, blunt snout which gives way to a relatively large, almost bulbous eye. These eyes, disproportionately large for its head size, are a clear adaptation to the low-light conditions of its environment. They are equipped with a high concentration of rod cells, specialized photoreceptors that excel at detecting movement and contrast in dim light, sacrificing color perception for extreme sensitivity. This allows the cookiecutter shark to perceive the faintest flickers of bioluminescence, or the subtle outlines of prey against the deep's vast darkness, an essential tool for navigation and hunting, where visual cues are fleeting and precious. Beneath the snout, the mouth is positioned ventrally on the underside of the head, a common characteristic among many shark species. However, the cookiecutter shark's mouth is no ordinary aperture. It is a marvel of biological engineering uniquely adapted for its peculiar parasitic feeding. The lips surrounding this mouth are fleshy and thick, almost suction cup-like in their texture and potential function. These specialized lips are believed to form a tight, adhesive seal against the body of its prey, creating a vacuum that helps to anchor the shark firmly in place during its feeding process. Imagine the soft, yielding grip of these lips, pressing against the slick skin of a whale holding fast as the shark prepares its surgical strike. Within this remarkably adapted mouth lies the true marvel of the cookiecutter shark, its teeth. These are not the scattered, individually replaceable teeth found in many other sharks. Instead, the cookiecutter shark possesses two distinct sets, each perfectly designed for its role in creating the iconic circular wound. The upper jaw is lined with approximately 30 to 37 small, slender, needle-like teeth, each acutely pointed. These upper teeth are believed to play a role in grasping, perhaps piercing, the initial surface of the prey, or assisting in the initial attachment. They are relatively delicate, almost like tiny, sharp hooks, designed for securing, not for cutting large sections of flesh. The lower jaw, however, holds the true cutting instruments. Here, a single row of 25 to 30 large triangular serrated teeth forms a continuous interlocking blade. These lower teeth are remarkably broad at their base, tapering to an acutely sharp point, and are deeply serrated along their edges, creating a formidable cutting surface. What is truly extraordinary about these lower teeth is their unified nature. They are not individual teeth, but rather form a single continuous saw-like unit. When one tooth is lost or damaged, the entire row is shed and replaced simultaneously, ensuring that the cutting edge remains perfectly intact and functional. This synchronized replacement is a testament to the precision required for its unique feeding method. The lower jaw itself is capable of extending outwards, creating a wider gape, and its musculature is exceptionally strong, designed to deliver a powerful rotational bite. Behind the head, the body extends into a sleek trunk, supported by a cartilaginous skeleton characteristic of all sharks. Its two dorsal fins are small and set far back on the body, positioned towards the caudal or tail region. These fins, along with its pectoral fins, which are also relatively small and paddle-like, provide stability and subtle maneuverability rather than propulsion. Unlike many other sharks, the cookiecutter shark lacks an anal fin, a feature that further contributes to its smooth, almost featureless underside. The caudal fin, or tail fin, is asymmetrical with the upper lobe, slightly longer than the lower, a design that likely provides efficient propulsion for short bursts of speed, essential for its quick strike and retreat feeding strategy. The skin of the cookiecutter shark is covered in minute dermal denticles, tiny tooth-like scales that give its surface a rough, sandpaper-like texture when stroked against the grain. These denticles reduce drag, allowing for smoother movement through the water. But perhaps the most captivating and defining anatomical feature beyond its mouth is the intricate pattern of bioluminescent organs, or photophores, that adorn its entire ventral surface. These light-producing cells are not randomly distributed, but form a complex, almost iridescent network, covering the shark's belly and flanks, extending even to the base of its fins. However, there is a striking exception to this luminous covering. A distinct unpigmented and non-luminescent collar of darker skin encircles its throat just behind the gill slits. This dark band, starkly contrasting with the glowing photophores surrounding it, is a crucial element of its predatory strategy. Scientists theorize that this dark collar, when viewed from below by a potential predator or prey, mimics the silhouette of a smaller fish. As the shark drifts upwards from the deeper, darker waters, its glowing underside, carefully modulated by its photophores, serves a dual purpose. It provides counter-illumination, matching the faint, filtered sunlight from above, effectively erasing its own silhouette against the dim sky for creatures looking up. But the dark collar breaks this camouflage, creating the illusion of a small, vulnerable fish silhouetted against the light. This remarkable bioluminescent display is not merely for camouflage, it is a sophisticated lure. Imagine a large tuna swimming hundreds of meters below the surface, glancing upwards. It might perceive a small, dark shape, seemingly isolated, struggling, and therefore an easy meal. Drawn closer by this deceptive beacon, the unsuspecting prey swims directly into the ambush zone of the cookiecutter shark. The shark, remaining perfectly still, waits for the optimal moment, its suction cup lips ready to attach its razor-sharp lower teeth, primed for their precise excavation. This intricate interplay of light and shadow, of mimicry and deception, elevates the cookiecutter shark to a master of silent, calculated predation. Internally, the cookiecutter shark also possesses adaptations for its deep-sea life. Like many other deep-sea sharks, it has a large liver rich in squalene, a low-density oil. This oily liver provides buoyancy, allowing the shark to maintain neutral buoyancy in the water column without expending significant energy on swimming. This passive buoyancy is crucial for a creature that spends much of its life drifting in the vast open ocean, conserving energy between infrequent feeding events. Its musculature, while not built for sustained high-speed pursuit, is powerfully developed around its head and jaws, enabling the rapid, forceful bite and suction necessary for its unique feeding method. Beyond the visible anatomy, the Cookiecutter shark possesses the full suite of advanced sensory systems characteristic of sharks. Its lateral line system, a series of neuromasts running along its flanks, detects subtle vibrations and pressure changes in the water, allowing it to sense the approach of larger creatures even in complete darkness. Its ampullae of Lorenzini specialized electroreceptors located around its snout can detect the faint electrical fields generated by the muscle contractions of other animals, providing another layer of sensory input in the lightless depths. Its olfactory sense, its sense of smell, is also highly developed, capable of detecting minute traces of blood or other chemical cues in the vast expanse of the ocean. Thus, the Cookiecutter shark, in its peculiar form, is a testament to the exquisite precision of natural selection. Every curve of its body, every specialized tooth, every luminous cell is a carefully honed instrument designed for a life of silent surgical predation in the deep. It is a creature that embodies the saying that great things come in small packages, or perhaps more accurately, that profound and unsettling power can reside within the most unassuming of forms. Its anatomy is a whispered story of adaptation, a narrative of how life finds a way, even in the most challenging and mysterious environments, to thrive through cunning and specialized design. As it drifts through the abyssal currents, it is truly an anatomical shadow, a master of deception waiting patiently its unique form, a perfect blueprint for its singular role in the deep ocean's intricate web of life. Unraveling the perfect bite. Having gently explored the peculiar form of Isistius brasiliensis, our focus now narrows, drawing closer to the very heart of its extraordinary identity, its dentition. This is where the silent surgeon truly reveals its mastery, for within its unassuming mouth lies an arrangement of teeth so specialized, so perfectly engineered, that it allows this diminutive shark to carve its signature mark with unparalleled precision. It is a story told in enamel and cartilage, a narrative of evolutionary refinement that speaks of astonishing effectiveness. Let us first consider the upper jaw, a delicate arc of bone that cradles a row of approximately 30 to 37 slender, narrowly pointed teeth. These are not the broad tearing teeth of a great white, nor the crushing plates of a bottom feeder. Instead, each upper tooth is an exquisitely sharp, almost needle-like spike, tapering to a fine point. Their form suggests a primary function of delicate piercing and anchoring. Imagine these tiny, sharp points arrayed in a neat row, designed to penetrate the outer layer of a victim's skin, perhaps providing the initial grip, a subtle purchase against the smooth, resilient surface of a whale or a dolphin. They are like a series of minute grappling hooks, holding the shark steady, preventing slippage as the more significant work of the lower jaw commences. Their small size and individual nature imply a role in stabilization, ensuring the shark remains firmly attached during the critical moments of its feeding process, a silent, almost imperceptible hold. Now, our attention descends to the lower jaw, where the true marvel of the Cookiecutter shark's predatory apparatus resides. Here, a singular continuous row of 25 to 30 teeth forms an unbroken, formidable cutting blade. These lower teeth are dramatically different from their upper counterparts. Each tooth is broad at its base, a robust triangular plate of enamel tapering sharply to an acutely pointed cusp. Along the cutting edge of each of these triangular teeth, a series of minute razor-sharp serrations are meticulously arrayed. These serrations are not merely decorative. They act like the teeth of a microscopic saw, enhancing the cutting efficiency, allowing the blade to slice through tough flesh and blubber with remarkable ease. What truly distinguishes this lower dentition is its unified nature. Unlike most sharks, where teeth are replaced individually as they are lost or worn, the cookie-cutter shark's entire lower jaw of teeth is interlocked, forming a single, cohesive unit. When a tooth is damaged or shed, the entire row is replaced simultaneously, ensuring that the cutting edge remains perfectly aligned, a seamless, continuous blade ready for its next surgical task. Imagine a finely crafted saw where every tooth is precisely angled and perfectly sharp, ready to perform its function without flaw. This synchronized replacement mechanism is a testament to the absolute necessity of maintaining a flawless cutting instrument for its unique feeding strategy. The process of tooth replacement is a slow, continuous migration, with new teeth forming behind the active row and slowly moving forward, eventually pushing out the old, worn blade, maintaining a perpetual state of readiness. The musculature surrounding these jaws is exceptionally powerful for the shark's size. While the cookie-cutter shark may not possess the sheer jaw strength to crush bone, it wields an impressive capacity for a rapid, forceful bite, and critically, a rotational movement. The lower jaw itself is not rigidly fixed, but is capable of protruding outwards, extending slightly from the head, which increases the effective gape and allows the unified blade to engage more deeply with the prey's flesh. This combination of a powerful, protrusible lower jaw and a continuous serrated blade is the key to its legendary precision. Now let us meticulously trace the sequence of the perfect bite, unraveling the intricate mechanics that allow Isistius brasiliensis to perform its silent surgery. The journey begins with the cookie-cutter shark's approach, often from the deeper, darker waters below its unsuspecting victim. As we discussed its bioluminescent lure, the dark collar against its glowing belly plays a crucial role in drawing larger prey, close inducing a sense of false security or curiosity. Once in close proximity, the shark makes its move. It first presses its specialized, fleshy, almost suction cup-like lips firmly against the body of its target. These lips are designed to create a tight, adhesive seal, generating a vacuum. Imagine the subtle yet powerful suction anchoring the shark to the smooth, yielding surface of a whale's flank or a dolphin's belly. This initial attachment is paramount, as it provides the stable platform from which the cutting operation will proceed, preventing the shark from being dislodged by the movement of its massive host. The upper needle-like teeth likely contribute to this initial grip, pricking the skin and securing the shark's position, ensuring there is no slippage, no deviation from the intended point of incision. With its body firmly anchored by the suction of its lips and the grip of its upper teeth, the cookie-cutter shark then brings its formidable lower jaw into play. The lower jaw protrudes slightly, extending the continuous serrated blade outwards. This blade, a unified arc of razor-sharp enamel, is pressed against the prey's flesh, initiating the cut. And here lies the true genius of its dentition. The shark does not simply bite down and pull. Instead, scientists believe it performs a highly coordinated rotational movement. Picture this as the lower jaw begins its incision. The cookie-cutter shark either spins its entire body around its longitudinal axis, or more subtly oscillates its head and jaw in a circular motion while maintaining the suction and grip of its upper jaw. This rotational action, combined with the continuous serrated blade of the lower teeth, acts like a living biological core drill. The teeth slice through the blubber and muscle, precisely excavating a perfect hemispherical plug of flesh. The vacuum created by its lips further assists in this process, helping to pull the plug of tissue cleanly away from the victim's body once it has been severed. It is a testament to natural engineering, a biological marvel that transforms a small cigar-shaped shark into a living surgical instrument. The result is the iconic, perfectly circular wound, a deep, scooped-out crater of flesh, typically 2 to 7 centimeters in diameter and often several centimeters deep. The edges of these wounds are remarkably clean, almost surgically precise, a direct consequence of the continuous sharp blade and the rotational cutting motion. The consistent size of these wounds across various prey species suggests a highly standardized and efficient mechanism, a testament to the uniformity of the cookie-cutter shark's dentition and biting technique. Once the plug of flesh is removed, the cookie-cutter shark releases its suction and detaches itself from its victim, swimming away into the anonymity of the deep, leaving behind only the telltale circular scar. This entire process is remarkably swift, minimizing the time the small shark spends in a vulnerable position, attached to a much larger, potentially agitated animal. The detached plug of flesh, rich in nutrients and calories, provides a substantial meal for a creature living in an energy-poor environment. This unique parasitic feeding strategy, enabled by its specialized dentition, offers significant evolutionary advantages. Firstly, it allows the cookie-cutter shark to exploit a food source that is largely inaccessible to other small predators, the vast biomass of large marine animals. It does not need to hunt and overpower prey of its own size or smaller. Instead, it takes a small, manageable portion from giants, a strategy of energy efficiency. Secondly, the rapid, precise bite minimizes the risk to the shark. A prolonged struggle with a large, powerful animal would be fraught with danger. By taking a quick, clean bite and swiftly retreating, the cookie-cutter shark avoids prolonged confrontation, ensuring its survival. The dentition of Isistius brasiliensis is a profound example of convergent evolution where distinct lineages independently evolve similar traits. While its method is unique, the underlying principle of specialized teeth for specific diets is a recurring theme in the natural world. Yet the cookie-cutter shark elevates this principle to an art form, crafting a feeding strategy that is both elegant in its simplicity and devastating in its effectiveness. Its teeth are not merely tools for consumption. They are instruments of precision, shaping its ecological niche and leaving an unmistakable signature across the vast living canvas of the deep ocean. As we slowly drift through the understanding of this remarkable dentition, we gain a deeper appreciation for the intricate details of life in the abyssal realm. The cookie-cutter shark, with its perfectly engineered cutting blade and its precise surgical technique, stands as a quiet testament to the endless ingenuity of evolution. It reminds us that even in the darkest, most mysterious corners of our world, life flourishes in forms that continually challenge our imagination, leaving behind perfectly circular whispers of their silent, profound existence. The precision of its bite is not just a biological curiosity, it is a fundamental pillar of its survival, a masterpiece of natural design, allowing it to thrive as the deep's most enigmatic and effective surgeon. bioluminescence in the abyssal zone. As we delve deeper into the life of Isistius brasiliensis, beyond the astonishing precision of its bite, we encounter an even more ethereal aspect of its existence, its mastery of light. In the vast, lightless expanse of the abyssal zone where sunlight becomes a distant memory, just a few hundred meters below the surface, light itself transforms into a precious and powerful tool. It is here in this realm of perpetual twilight and utter darkness that bioluminescence, the production of living light, becomes a silent, pervasive language, spoken by countless organisms. Imagine, if you will, a world where day and night cease to exist in any conventional sense. Below 200 meters, the ocean enters the mesopelagic zone, a realm of perpetual twilight, where only the faintest ghostly blue light from the sun's surface penetrates. By 1,000 meters, the bathypelagic zone begins a kingdom of absolute blackness, broken only by the fleeting, self-generated flashes of living beings. In this profoundly alien environment, creatures have evolved an astonishing array of strategies to communicate, defend, and hunt using light produced from within their own bodies. This light is not heat-generating, but a cold light, born from complex chemical reactions involving molecules like luciferin and the enzyme luciferase, transforming chemical energy directly into photons. The Cookiecutter Shark, in its quiet brilliance, is a master of this luminous deception. Its entire ventral surface, from its blunt snout to the base of its caudal fin, is adorned with countless, minute light-producing organs called photophores. These tiny biological lanterns are not merely scattered randomly across its skin. They form an intricate, almost iridescent network capable of emitting a soft, ethereal glow. This glow is typically a pale blue-green, the predominant wavelength of light that penetrates deepest into the ocean, making it the most effective color for communication and camouflage in the deep. The primary function of this widespread bioluminescence on the Cookiecutter Shark's underside is a sophisticated form of camouflage known as counter-illumination. Picture yourself looking upwards from the depths of the ocean. Even in the mesopelagic zone where light is scarce, any object silhouetted against the faint filtered sunlight from above would be visible. To avoid detection, many deep-sea creatures, including the Cookiecutter Shark, employ counter-illumination. They precisely match the intensity color and angular distribution of the dim, ambient light, filtering down from the surface with the light emitted from their own photophores. This meticulous matching allows the shark to effectively erase its own silhouette. It becomes in essence invisible from below, blending seamlessly into the background light. Imagine a ghostly form, its edges softened and dissolved by its own emitted light, becoming one with the surrounding dimness. This is not a simple flick of a switch. The shark possesses the remarkable ability to modulate the intensity of its emitted light, adjusting it as it moves through different depths and light levels. This ensures that its counter-illumination remains perfectly calibrated, a silent, continuous act of disappearing into the environment. For a creature that primarily ambushes its prey, remaining unseen until the very last moment is an invaluable evolutionary advantage, a fundamental pillar of its hunting strategy. However, the Cookiecutter Shark's bioluminescent display holds a deeper, more cunning secret, a profound layer of deception that elevates its predatory strategy to an art form. While its entire ventral surface glows with counter-illumination, there is one striking exception: a distinct unpigmented and non-luminescent collar of darker skin that encircles its throat just behind the gill slits. This dark band, starkly contrasting with the glowing photophores that surround it, is the key to its luminous lure. Imagine the scene from the perspective of a large, unsuspecting deep-sea predator. Perhaps a powerful tuna or a swift swordfish swimming hundreds of meters below the surface. Its eyes, adapted for low light, are constantly scanning the waters above for any sign of prey. As the cookie-cutter shark slowly drifts upwards from the darker abyssal depths, its counter-illuminated belly effectively vanishes, but the dark collar, that non-luminous band, creates a startling illusion. Against the faint, glowing background of the shark's own body, this dark band forms a perfect, small silhouette. Scientists theorize that this dark collar, when viewed from below, precisely mimics the silhouette of a much smaller, more vulnerable fish. Perhaps a tiny, struggling cephalopod or a diminutive schooling fish. The larger predator, perceiving this isolated, seemingly defenseless target, is drawn closer by the promise of an easy meal. It approaches the luminous deception, its predatory instincts overriding any caution, focusing intently on that small, dark shape. The cookie-cutter shark, meanwhile, remains perfectly still, a master of patience, waiting for the optimal moment. As the unsuspecting victim draws near, lured by the deceptive beacon, it swims directly into the ambush zone of the cookie-cutter shark. At this precise moment, the shark, which had been camouflaged by its counter-illumination, is perfectly positioned to execute its unique parasitic attack. The prey, focused on the small, dark fish silhouette, fails to perceive the larger camouflaged body of the cookie-cutter shark until it is too late. The shark's specialized lips then quickly form a tight suction seal. Its upper teeth grip, and its formidable lower jaw, with its continuous serrated blade, performs its precise rotational cut. The entire sequence from lure to bite is a testament to the elegant efficiency of this luminous deception. The evolutionary advantages of this sophisticated bioluminescent lure are profound. In the energy-poor environment of the deep sea, where food is scarce and encounters are often fleeting, a hunting strategy that conserves energy and maximizes success is paramount. The cookie-cutter shark does not expend valuable energy in long, arduous pursuits. Instead, it employs a passive sit-and-wait strategy using light to bring the prey directly to it. This opportunistic parasitism allows it to tap into the vast biomass of large marine animals without the need for high-speed chases or prolonged struggles. It is a testament to the fact that in the deep, cunning and specialized adaptation can be far more effective than brute force. Furthermore, the specific wavelength of the cookie-cutter shark's bioluminescence, typically blue-green, is crucial. This is the color of light that travels furthest in oceanic water, making its lure visible over greater distances and its counter-illumination more effective in blending with the ambient light. The ability to control the intensity of its light, likely through neurological or hormonal mechanisms, further refines its deception, allowing it to adapt its camouflage and lure to varying conditions of depth and ambient light. While the theory of the dark collar as a lure is widely accepted among scientists, direct observation of this specific hunting behavior in the wild remains exceedingly rare. The deep ocean is a vast and challenging environment to study, and the cookie-cutter shark, with its elusive nature and deep-dwelling habits, adds another layer of difficulty. Our understanding is largely built upon meticulous anatomical studies, the consistent patterns of its bites, and the principles of deep-sea ecology and bioluminescence that we have observed in other species. Yet the elegance and effectiveness of this hypothesized mechanism resonate with the profound ingenuity of natural selection. The luminous deception of the cookie-cutter shark is more than just a biological curiosity. It is a profound illustration of how life adapts and innovates in the most extreme environments. It speaks of a world where light born from within can be a tool for invisibility, a beacon for predation, and a silent language spoken in the profound darkness. As the soft glow of these deep-sea photophores paints a living, shifting tapestry of light and shadow, we are reminded of the endless wonders that still await our gentle understanding in the dreaming depths of the ocean. The cookie-cutter shark, with its subtle, glowing belly and its dark, deceptive collar, drifts through this world as a true master of light, a silent, luminous shadow, forever weaving its intricate dance of survival in the abyssal zone. Habitat and vertical migration. From the intricate dance of light within the cookie-cutter shark's very being, our journey now expands to encompass the vast, encompassing stage upon which this luminous deception unfolds the deep ocean itself. This is a realm defined not by fixed landscapes, but by shifting columns of water, by gradients of light, temperature, and pressure, where existence is a continuous drift through immense, silent volumes. The habitat of Isistius brasiliensis is the open pelagic zone, the boundless expanse of water far from continental shelves, stretching across the tropical and warm, temperate oceans of the world. It is a truly cosmopolitan species, its presence recorded from the Atlantic to the Pacific, from the Indian Ocean to the fringes of the subpolar gyres, a testament to its adaptability and the vastness of its chosen domain. Within this colossal liquid environment, the ocean is vertically stratified, divided into distinct layers, each with its own unique characteristics. For the cookie-cutter shark, two primary zones define its daily existence: the mesopelagic, or twilight zone, and the bathypelagic, often referred to as the midnight zone. The mesopelagic zone begins where the last glimmer of direct sunlight fades, typically around 200 meters below the surface, and extends downwards to approximately 1,000 meters. Here, the light is an ethereal, ghostly blue, a mere whisper of the sun's brilliance, gradually diminishing until it is indistinguishable from the surrounding dimness. It is a world of perpetual dusk, where shadows stretch long and indistinct. Below 1,000 meters, the ocean plunges into the bathypelagic zone, a realm of absolute, unyielding darkness. Here, no ray of sunlight has ever pierced, and the only illumination comes from the ephemeral flashes of bioluminescent organisms, like tiny living stars in an endless night. The pressures in these depths are immense, increasing by 1 atmosphere for every 10 meters of descent. At 1,000 meters, the pressure is a crushing 100 atmospheres, equivalent to the weight of a heavy car resting on a postage stamp. The temperature is uniformly cold, hovering just above freezing, typically between 2 and 4 degrees Celsius, a frigid, stable environment that demands specialized physiological adaptations for survival. It is within these profound vertical dimensions that the cookie-cutter shark orchestrates its life, engaging in one of the most widespread and awe-inspiring migrations on our planet: diurnal vertical migration. This is a rhythmic, daily journey, an ascent and descent through hundreds, sometimes thousands of meters of water, timed precisely with the subtle ebb and flow of solar light at the surface. During the daylight hours, when the sun's rays penetrate the upper layers of the ocean, the cookie-cutter shark retreats to the sanctuary of the deeper bathypelagic zone, often dwelling at depths exceeding 1,000 meters, sometimes even descending to 3,000 meters or more. In these profound depths, the shark finds refuge from visual predators that inhabit the shallower, more illuminated waters. while its counter-illumination serves as a remarkable camouflage retreating to absolute darkness, offers the ultimate concealment. The deeper, colder water also aids in conserving energy. The cookie-cutter shark, like many deep-sea creatures, possesses a relatively slow metabolism, and the cooler temperatures further reduce its metabolic rate, allowing it to expend less energy simply existing. Imagine it drifting silently, almost effortlessly in the crushing darkness, a phantom form conserving its vital reserves, patiently awaiting the sun's departure. As the sun begins its slow descent below the horizon and the last vestiges of twilight fade from the surface, a colossal, synchronized movement begins across the world's oceans. Billions upon billions of organisms, from microscopic zooplankton to larger fish and cephalopods, embark on an upward journey, ascending from the depths into the shallower, food-rich waters of the mesopelagic and even epipelagic surface zones. This is the largest biomass migration on Earth, a nightly exodus driven by the promise of abundant food. The cookie-cutter shark is an active participant in this grand, silent procession. Under the cloak of darkness, the cookie-cutter shark begins its own slow, deliberate ascent, rising from its daytime sanctuary in the bathypelagic zone. It typically ascends to shallower depths, often within the upper mesopelagic zone, sometimes even reaching the surface waters, though usually remaining below 100 meters. This nocturnal migration is driven by a singular, compelling need: access to prey. The very animals that hide in the depths during the day, like large pelagic fish, tuna billfish, and even marine mammals such as whales and dolphins, are now foraging in these shallower waters, taking advantage of the darkness to hunt their own prey, or simply to feed on the vertically migrating smaller organisms. The cookie-cutter shark's adaptations are perfectly suited for this arduous daily journey. Its large, oily liver, rich in low-density squalene, provides essential buoyancy, allowing it to maintain neutral buoyancy throughout the water column. This means it can ascend and descend with minimal expenditure of muscular energy, conserving its precious resources in an environment where every calorie counts. Without this natural flotation device, the shark would have to constantly swim to avoid sinking, an unsustainable energy drain for such a long migration. Imagine the shark, a living submarine adjusting its internal chemistry to perfectly match the density of the surrounding water, allowing it to hover and drift with effortless grace. During its nocturnal ascent into the twilight zone, the cookie-cutter shark's bioluminescent capabilities become critically important. Its counter-illumination, which we explored in the previous chapter, allows it to blend seamlessly with the faint ambient light filtering down from the surface, effectively erasing its silhouette from the view of any upward-looking predators. Simultaneously, its dark gular collar, acting as a deceptive lure, becomes active, drawing unsuspecting larger prey towards it. This precisely timed activation of its bioluminescent system, perfectly synchronized with its vertical migration, maximizes its chances of a successful ambush. It transforms from an invisible drifter into a cunning hunter, using light as both shield and spear. The advantages of this diurnal vertical migration are manifold. Firstly, it provides access to a wider range of food sources. By ascending at night, the cookie-cutter shark can encounter the larger, more active prey that reside in shallower waters, creatures that would be too fast or too visually acute to approach during daylight hours. Secondly, it offers a dual strategy for predator avoidance. During the day, the sheer depth and darkness of the bathypelagic zone provide ultimate concealment. At night, its counter-illumination ensures it remains hidden even as it ventures into slightly brighter waters. This sophisticated balance of refuge and foraging is a hallmark of successful deep-sea survival. The sheer scale of this daily migration is difficult to grasp. A journey of 1,000 meters or more, undertaken by countless millions of organisms, every single day across the vastness of the global ocean. It is a silent, unseen rhythm that profoundly shapes marine ecosystems, influencing nutrient cycling, carbon sequestration, and the distribution of biomass. The Cookiecutter Shark, a relatively small player in this grand ballet, nevertheless performs its part with exquisite precision, its very existence intertwined with this colossal movement of life. Studying the precise migratory patterns of the Cookiecutter Shark presents immense challenges. Its deep-dwelling, elusive nature combined with the vastness of its pelagic habitat makes direct observation incredibly rare. Scientists rely on a combination of indirect evidence analyzing stomach contents of captured specimens, observing bite marks on prey, and utilizing sophisticated acoustic tracking technologies or deep-sea cameras, though these are often limited in range and duration. The very act of bringing a cookiecutter shark to the surface for study can disrupt its delicate physiology as it is adapted to extreme pressure changes. Therefore, much of our understanding of its daily movements is inferred from the broader patterns of diurnal vertical migration observed in other deep-sea fauna, and from the shark's unique anatomical and physiological adaptations. The cookiecutter shark's life in the twilight zone is a continuous, graceful negotiation with its environment. It is a slow, methodical existence punctuated by swift, decisive strikes. Its entire being is a finely tuned instrument designed to navigate the immense vertical distances, to withstand the crushing pressures, to thrive in the frigid darkness, and to exploit the fleeting moments when predator and prey momentarily align. Its drifting existence is a testament to the profound and often unseen forces that govern life in the deep, a silent ballet choreographed by the sun and the moon, played out in the boundless dreaming waters of our planet. As we contemplate this daily journey, we are reminded of the hidden rhythms of the ocean, the constant movement of life, and the enduring mystery of creatures like the cookiecutter shark, forever drifting forever, adapting in the twilight zone. Striking from the shadows. Having drifted through the vast vertical world that is the cookiecutter shark's domain, and having marveled at its luminous deception, we now arrive at the very heart of its enigmatic existence, the moment of attack. This is where its peculiar form, its specialized dentition, and its mastery of light converge into a singular, astonishing act of predation, a silent strike from the shadows that leaves an indelible mark. It is a sequence of events so precise, so efficient, that it transforms this small creature into one of the ocean's most formidable, albeit unusual, hunters. The stage for this drama is set in the twilight zone or even the shallower reaches of the midnight zone during the nocturnal ascent. The cookiecutter shark, having risen from its deep-sea sanctuary, now drifts almost imperceptibly, its body held aloft by its oily liver, its photophores carefully modulated for counter-illumination. From the perspective of an unsuspecting victim scanning the waters above the shark's glowing ventral surface, might appear to be nothing more than a continuation of the faint ambient light, its silhouette effectively dissolved. Yet the dark collar around its throat remains a compelling, non-luminous void against the soft glow, a cunning mimicry of a small, vulnerable fish. Imagine a large, powerful tuna, its sleek, muscular body cutting through the water with effortless grace, its keen senses attuned to the subtle vibrations and chemical trails that betray the presence of prey. Or perhaps a deep-diving sperm whale, its massive form moving with slow, deliberate power, filtering the water for squid. Both are giants of the ocean, formidable in their own right, and utterly unaware of the small, silent shadow that drifts towards them. The cookiecutter shark, for its part, is not relying solely on its visual lure. Its highly developed lateral line system, a series of sensory pores running along its flanks, detects the minute pressure waves generated by the movement of these larger animals, even from a considerable distance. Its ampullae of Lorenzini, those specialized electroreceptors around its snout, sense the faint electrical fields emanating from the muscle contractions of its potential host. And its acute sense of smell, capable of detecting traces of blood or other organic compounds, provides another layer of sensory input, guiding it through the vast, dark expanse. As the target approaches, drawn closer by the deceptive allure of the dark collar, the cookiecutter shark remains motionless, a predator of profound patience. Its body, approximately 50 centimeters in length, is a tiny fraction of the size of its chosen meal, sometimes less than 1% of its victim's mass. This immense disparity in size is a critical element of the attack, for it necessitates a strategy of precise surgical extraction rather than a full-scale confrontation. The shark conserves its energy, allowing the prey to come to it, minimizing any strenuous exertion until the very last critical moment. The moment of truth arrives. The unsuspecting large fish or marine mammal passes within striking range. With a sudden swift burst of movement born from powerful tail thrusts, the cookiecutter shark launches itself forward, closing the final distance. Its blunt snout makes initial contact, and its specialized fleshy lips immediately come into play. These lips, soft yet remarkably strong, press firmly against the victim's skin, creating a tight, vacuum-like seal. Imagine the subtle yet powerful adhesion holding the shark's body securely against the smooth, resilient surface of the larger animal. This initial attachment is paramount, for it provides the stable anchor from which the entire cutting operation will proceed, preventing the shark from being dislodged by the sheer momentum or subtle movements of its colossal host. Simultaneously with the suction, the shark's upper jaw, armed with its row of slender, needle-like teeth, engages. These sharp-pointed teeth, perhaps 30 to 37 in number, pierce the outer layers of the prey's skin and blubber, providing an additional vital grip. They act like a series of tiny, perfectly aligned grappling hooks, reinforcing the suction seal and ensuring that the shark remains firmly affixed. This combination of powerful suction and precise piercing creates an unyielding hold, transforming the small shark into an immovable, albeit temporary, appendage on the body of its much larger victim. With its body now firmly anchored, the cookiecutter shark prepares its signature maneuver. Its lower jaw, a marvel of biological engineering, protrudes outwards, extending the continuous serrated blade of its 25 to 30 interlocking teeth. This formidable cutting instrument, a single unified arc of razor-sharp enamel, is pressed against the prey's flesh, initiating the incision. And here the true genius of the cookiecutter shark's attack unfolds. It does not simply bite down and tear. Instead, scientists believe it performs a highly coordinated rotational movement. Picture this in slow motion. The shark's lower jaw, now engaged, begins to carve into the flesh. Simultaneously, the shark either rotates its entire body around its longitudinal axis, or more subtly oscillates its head and jaw in a precise circular motion. This rotational force, combined with the continuous saw-like action of its serrated lower teeth, acts like a living biological core drill. The teeth slice cleanly through the blubber muscle, and other soft tissues, excavating a perfect hemispherical plug of flesh. The vacuum created by its lips further assists in this process, helping to pull the severed plug of tissue cleanly away from the victim's body once the cut is complete. It is a testament to the elegant efficiency of natural selection, a biological masterpiece of surgical precision. The entire process from initial contact to the removal of the flesh plug is remarkably swift, likely taking only a few seconds. This rapid execution is crucial, minimizing the time the small shark spends in a vulnerable position attached to a potentially agitated, much larger animal. The victim caught by surprise may only register a sudden, sharp pain before the shark detaches. Once the plug of flesh is secured, the cookie-cutter shark releases its suction and grip, detaching itself from its victim. It then retreats back into the anonymity of the deep, disappearing once more into the vast, lightless expanse, leaving behind only the telltale circular wound. These wounds, typically 2 to 7 centimeters in diameter and often several centimeters deep, are astonishingly clean-edged, a direct consequence of the continuous sharp blade and the precise rotational cutting motion. They are a silent circular signature etched onto the living canvas of the ocean's giants, a testament to an unseen, meticulous attacker. The detached plug of flesh rich in nutrients and calories provides a substantial meal for the cookie-cutter shark, a critical energy boost in the food, scarce environment of the deep. This parasitic feeding strategy offers profound evolutionary advantages. It allows the small shark to exploit a vast biomass of food that would otherwise be entirely inaccessible. It bypasses the need for high-speed chases, prolonged struggles, or the overwhelming of prey, all of which would be energy-intensive and dangerous for a creature of its size. Instead, it relies on stealth deception and precise surgical strikes, a method that conserves energy and minimizes risk. While the evidence of the cookie-cutter shark's attacks is abundant in the form of countless circular scars on marine animals and even man-made objects, direct observation of this enigmatic attack in the wild remains exceedingly rare. The deep ocean is a challenging environment to study, and the cookie-cutter shark's elusive, deep-dwelling nature, combined with the fleeting nature of its strike, makes it an almost mythical event to witness firsthand. Our understanding is meticulously pieced together from forensic evidence on victims' detailed anatomical studies of the shark itself and the principles of deep-sea ecology and bioluminescence. The enigmatic attack of the cookie-cutter shark, striking from the shadows, is a profound illustration of the boundless ingenuity of evolution. It reveals a world where size does not always dictate dominance, and where specialized adaptations can grant even the smallest inhabitants an extraordinary power. It is a silent, precise ballet of predator and prey, played out in the profound darkness of the deep, a testament to the enduring mysteries that still await our gentle understanding in the dreaming waters of our planet. As we contemplate this swift, unseen strike, we are reminded that even in the most serene depths, life finds its own unique and often unsettling ways to survive, leaving behind perfectly circular whispers of its silent, profound existence. A parasitic strategy of the ocean. From the swift, precise execution of its strike, our gaze now widens, encompassing the profound ecological implications of the cookie-cutter shark's actions. We delve into the very essence of its survival strategy, feasting on giants, a highly specialized form of parasitism that defines its role in the vast, dreaming ocean. This is not the conventional predation of hunter and hunted, but a more subtle yet equally impactful interaction, a testament to the myriad ways life finds sustenance in the most challenging of environments. Parasitism, in its broadest sense, describes a relationship where one organism, the parasite, lives on, or in another organism, the host, deriving nutrients at the host's expense. Crucially, a true parasite typically does not kill its host immediately, as its survival depends on the continued existence of the host, at least for a period. The cookie-cutter shark, Isistius brasiliensis, fits this definition with an almost unsettling perfection. It does not pursue a kill. It seeks a meal, a single nutrient-rich plug of flesh, leaving its colossal host to continue its journey, albeit with a fresh wound. The roster of its victims is astonishing in its breadth and scale. Imagine the world's largest living mammal, the blue whale, a creature of immense grace and power, stretching over 30 meters in length and weighing over 150 tons. Even this leviathan, a true giant of the deep, bears the silent circular scars of the cookie-cutter shark. Sperm whales, with their massive blunt heads and deep-diving prowess, frequently exhibit these telltale marks. Dolphins and porpoises, sleek and swift, are also common hosts, their smooth skin often adorned with multiple perfectly round craters. Seals and sea lions, agile hunters of the coastal waters, carry the same indelible signature, proving the shark's reach extends even to pinnipeds that might venture into its pelagic domain. Beyond marine mammals, the cookie-cutter shark preys upon an impressive array of large fish. Tuna, those torpedo-shaped marvels of speed and endurance, are frequent targets. Swordfish, with their formidable bills, and marlin, known for their acrobatic leaps, also bear witness to the cookie-cutter's bite. Even other much larger sharks, such as great whites, makos, and basking sharks, have been found with these distinctive circular wounds. It is a testament to the cookie-cutter shark's audacity and its unique predatory adaptations that it can approach and feed upon creatures many hundreds, even thousands of times its own diminutive size. A 50-centimeter shark extracting a plug of flesh from a 30-meter whale is a disproportionate interaction that challenges our conventional understanding of predator-prey dynamics. Why has such a peculiar and seemingly audacious strategy evolved? The answer lies in the harsh, energy-poor environment of the deep ocean. In the bathypelagic and mesopelagic zones, food is scarce, and the metabolic costs of survival are high. Active hunting involving prolonged chases and struggles would be prohibitively expensive in terms of energy expenditure for a small, deep-sea shark. The cookie-cutter shark's parasitic strategy is a masterpiece of energy conservation and opportunistic efficiency. By taking a small, calorically dense plug of flesh and blubber from a much larger animal, the shark gains a substantial meal, without expending the immense energy required to locate, pursue, and overpower prey of its own size. Imagine the sheer caloric value contained within a single 2 to 7 centimeter plug of whale blubber or tuna muscle. It is a concentrated burst of energy, a vital fuel source for a creature existing in a realm of scarcity. This strategy allows the cookie-cutter shark to tap into the vast biomass of the larger pelagic fauna, a food source that would otherwise be entirely inaccessible to a small, slow-moving, deep-sea predator. It is a clever bypass, a way to access the riches of the surface world without having to truly live there. Furthermore, this method minimizes risk. Engaging in a direct, prolonged confrontation with a powerful, potentially aggressive host, like a large shark or a whale, would be fraught with danger for a small cookie cutter. The quick surgical strike, followed by an immediate retreat into the anonymity of the deep, ensures the shark's safety. It is a hit-and-run tactic, a silent raid that avoids the perils of sustained combat. The sheer speed and precision of the bite, enabled by its specialized dentition and powerful jaw musculature, ensures that the entire process is completed in a matter of seconds, reducing the window of vulnerability. This unique parasitic niche also means that the cookie-cutter shark faces very little direct competition for its specific food source. While other deep-sea creatures are scavengers or ambush predators of smaller organisms, few, if any, employ this exact method of taking living tissue from large, active hosts. It is a specialized ecological role carved out through millions of years of evolutionary refinement, allowing Isistius brasiliensis to thrive where others cannot. The impact on the host, while generally not immediately lethal, is not insignificant. A single cookie-cutter shark bite, though small in proportion to the host's body, can be quite deep, penetrating through skin and blubber into muscle tissue. This creates an open wound that is susceptible to infection, especially in the warm, bacterial-laden surface waters, where many of these hosts spend their time. Imagine the vulnerability of such a wound exposed to the myriad microorganisms of the ocean. While marine mammals and large fish possess remarkable healing capabilities, multiple bites can accumulate over time, leading to significant scarring. Some individuals have been observed with dozens, even hundreds of cookie-cutter shark scars across their bodies, a testament to repeated encounters with these persistent deep-sea surgeons. These accumulated wounds can have subtle yet detrimental effects on the host. Large, deep lesions could potentially affect swimming efficiency, reducing the animal's speed or agility, which in turn could impact its ability to hunt or escape predators. Infected wounds could lead to systemic illness, weakening the host and making it more vulnerable to other threats. For animals already under stress from environmental factors, pollution, or other injuries, a heavy burden of cookie-cutter shark bites could tip the balance towards ill health. Scientists observe these scars as a form of biological tagging, a living record of the encounters between the giants of the ocean and this small, enigmatic parasite. Compared to other forms of predation, the cookie-cutter shark's strategy stands alone. It is not an active pursuit predator like a mako shark chasing a tuna. It is not a filter feeder like a baleen whale sifting plankton. Nor is it a scavenger waiting for carcasses to fall from above. It is a living, breathing, parasitic core sample extractor, a creature that has perfected the art of taking just enough without completely destroying its source of sustenance. This delicate balance is key to its long-term success as a parasite. The success of this parasitic strategy is deeply intertwined with its unique anatomy, which we have previously explored. The specialized fleshy lips that create a powerful vacuum seal the needle-like upper teeth for initial grip, and most critically, the continuous serrated blade of its lower jaw designed for a precise rotational cut. All these elements converge to make the perfect bite, not just a mechanical action, but the very foundation of its parasitic lifestyle. Without this exquisite precision, the strategy would fail. The shark would either be dislodged, inflict insufficient damage, or cause too much harm, jeopardizing its future food supply. The cookie-cutter shark's feasting on giants offers a profound insight into the intricate, often unseen dynamics of marine ecosystems. It reminds us that even the smallest players can exert significant influence, shaping the health and behavior of the largest creatures on Earth. Its parasitic strategy is not merely a biological curiosity, it is a fundamental pillar of its survival, a testament to the endless ingenuity of evolution in adapting life to the most extreme and challenging environments. As we contemplate this silent, surgical interaction, we are reminded of the hidden rhythms of the ocean, the constant negotiation for sustenance, and the enduring mystery of creatures like the cookie-cutter shark, forever leaving its perfectly circular whispers across the vast living canvas of the deep. Encounters beyond biological prey. Having explored the silent surgical efficiency with which the cookie-cutter shark feasts upon the living giants of the ocean, our journey now takes a surprising turn, revealing an even more perplexing facet of its predatory behavior. Beyond the warm flesh and blubber of marine animals, Isistius brasiliensis has left its unmistakable signature upon objects of cold, hard steel, upon the very technology humanity has sent into the deep. These are the scars on steel. Mysterious circular marks etched onto submarines, oceanographic instruments, and even vital underwater cables, forcing scientists and engineers to reconsider the boundaries of this small shark's enigmatic attacks. The first documented instances of these non-biological attacks emerged in the mid-20th century, coinciding with the rise of deep-sea exploration and the deployment of extensive underwater infrastructure. Imagine for a moment the vast, silent hulks of nuclear submarines designed to navigate the abyssal depths with stealth and precision. These formidable vessels, constructed from high-strength steel and equipped with sophisticated sonar domes and rubberized coatings, were thought to be impervious to the biological threats of the deep. Yet upon their return to port, engineers and crew began to discover peculiar, perfectly circular indentations and gouges on their hulls, sonar domes, and even the pressurized acrylic windows of observation submersibles. These marks, typically 2 to 7 centimeters in diameter, precisely matched the size and shape of the wounds observed on marine animals. The edges were clean, as if a specialized cutting tool had been meticulously applied. For a time, the source of these enigmatic blemishes remained a profound mystery. Theories ranged from unknown deep-sea organisms with powerful jaws to environmental abrasion or even structural fatigue. The idea that a small 50-centimeter shark could inflict such damage on hardened steel or tough rubber seemed utterly improbable, almost fantastical. However, as the evidence accumulated and the distinctive signature of the cookie-cutter shark's bite became more widely recognized, the truth slowly began to surface. It was the Isistius brasiliensis, the silent surgeon of the deep, that was leaving its indelible mark, not only on flesh, but on formidable man-made structures. The revelation was startling, prompting a re-evaluation of the shark's power and its sometimes indiscriminate predatory instincts. One of the most notable incidents occurred in the 1970s, when the sonar domes of US Navy submarines protected by thick neoprene rubber began to suffer repeated damage. These domes, critical for the submarine's navigation and detection capabilities, were found with clean, circular chunks of rubber precisely removed, exposing the delicate equipment beneath. The cost of repairs and the operational disruptions were significant. Scientists meticulously examined the damaged domes, comparing the bite marks to those found on marine animals, and the conclusion was undeniable: the cookie-cutter shark was the culprit. The question naturally arises: why would a cookie-cutter shark attack a submarine or a sonar dome? These are not sources of food. Scientists have put forth several theories, each contributing to our understanding of this perplexing behavior. One prevailing hypothesis suggests that the shark's attack is a case of mistaken identity, driven by its sophisticated bioluminescent lure. Imagine a deep-sea submersible slowly moving through the perpetual twilight. Its artificial lights, its hum of machinery, and perhaps even its electromagnetic fields might inadvertently mimic the bioluminescent patterns or the subtle electrical signatures of potential prey. The dark collar of the cookie-cutter shark, which acts as a lure against its glowing belly, might be triggered by the contrast between the submersible's lights and its darker hull. The shark, perceiving what it believes to be a vulnerable, smaller organism, launches its attack with the same precision it would apply to a whale. It is a case of its finely tuned predatory instincts being misdirected by the unfamiliar signals emanating from human technology. The shark perceives a potential meal, and its ancient instinctual programming takes over regardless of the material it encounters. Another theory posits that the shark might be attracted to the electromagnetic fields generated by underwater cables or the operational machinery of submersibles. Sharks possess ampullae of Lorenzini highly sensitive electroreceptors, capable of detecting faint electrical impulses such as those produced by muscle contractions of prey. It is conceivable that the electrical currents flowing through power cables or the operational hum of submersibles create electrical fields that, to a cookie-cutter shark, resemble the bioelectric signatures of living organisms. Drawn by these intriguing, albeit artificial signals, the shark investigates and, in its characteristic manner, takes an exploratory bite. The impact of these attacks extends beyond superficial damage. In some instances, the bites on sonar domes have been deep enough to compromise the dome's integrity, necessitating costly repairs and dry dock time. Even more critically, the cookie-cutter shark has been implicated in damage to submarine cables, the vital arteries of global communication that crisscross the ocean floor. While rare, a bite on a thin, unarmored section of a fiber optic cable could potentially disrupt data transmission, leading to communication outages. Imagine the minute yet powerful teeth of this small shark, capable of gnawing through the protective layers of a high-tech cable, a silent act of sabotage from the deep. The resilience of the cookie-cutter shark's teeth and its biting mechanism is truly remarkable when considering its ability to damage such tough materials. Its continuous serrated lower jaw, designed to slice through blubber and muscle, proves equally effective against neoprene rubber fiberglass and even some softer metals or coatings. The powerful suction of its lips and the rotational cutting motion allow it to extract a clean plug of material, regardless of whether it is organic tissue or man-made polymer. The shark's teeth, though small, are incredibly sharp and robust, capable of withstanding the forces required to penetrate these foreign substances. These encounters highlight the unique challenges of operating human technology in the deep ocean. We design our vessels and instruments to withstand immense pressure, extreme cold, and corrosion. But the subtle biological threats, like the precise surgical bite of a cookie-cutter shark, often remain unforeseen. These scars on steel serve as a quiet reminder that even in the most remote and seemingly uninhabited reaches of the ocean, life finds a way to interact with and sometimes disrupt human endeavors. Studying these non-biological attacks provides valuable insights into the cookie-cutter shark's sensory world and its predatory instincts. It reinforces the understanding that its attacks are primarily driven by an instinctual response to specific stimuli, be it a visual lure or an electromagnetic field, rather than a conscious targeting of food. The shark is simply responding to its environment in the way it has evolved to, and sometimes that environment includes our advanced technology. As we slowly drift through the contemplation of these unexpected encounters, we are reminded of the profound disconnect between the human-engineered world and the ancient, instinct-driven life of the deep ocean. The cookie-cutter shark, leaving its circular marks on both living flesh and inanimate steel, stands as a quiet, persistent enigma, a deep-sea creature that continues to challenge our assumptions about predation and interaction in the vast, dreaming waters of our planet. Its ability to scar steel is not merely a curiosity. It is a testament to its evolutionary success its unwavering predatory drive, and the enduring mystery of a small shark that truly strikes from the shadows, leaving its indelible signature on everything it encounters. Reproduction in the deep sea void. Having navigated the curious encounters of the cookie-cutter shark with the cold, hard surfaces of human technology, our journey now turns inwards towards the very heart of its continued existence, the cycle of life itself. In the vast, silent void of the deep ocean where light is a memory and encounters are rare, the process of reproduction for Isistius brasiliensis is as enigmatic and sparsely observed as much of its life. Yet through careful study of captured specimens and an understanding of deep-sea elasmobranch biology, scientists have pieced together a picture of how this small, mysterious shark perpetuates its lineage in the perpetual darkness. Like all sharks, the cookie-cutter shark reproduces sexually with internal fertilization. The male possesses a pair of specialized pelvic fins called claspers, which are used to transfer sperm to the female. However, direct observation of mating behavior in the wild is exceedingly rare given the shark's deep-dwelling pelagic nature. Imagine the immense challenge of witnessing such an intimate act in a realm spanning thousands of meters of water, where individuals are widely dispersed and opportunities for interaction are fleeting. Scientists therefore infer much of this process from anatomical evidence and comparative studies with other deep-sea shark species. What is known with greater certainty is the cookie-cutter shark's reproductive strategy. It is ovoviviparous. This means that the female produces eggs, but these eggs are not laid externally. Instead, they are retained within her oviducts where they hatch internally. The developing embryos encased within their egg membranes draw their nourishment primarily from the yolk sac, a rich store of nutrients provided by the mother. There is no direct placental connection between the mother and the developing embryos, as seen in viviparous mammals or some advanced sharks. This ovoviviparous mode of reproduction is common among many deep-sea sharks, and skates offering several advantages in their challenging environment. One of the primary benefits of ovoviviparity in the deep-sea void is the protection it offers to the developing young. By retaining the eggs internally, the mother shields them from the harsh external environment, the crushing pressures, the frigid temperatures, and the myriad predators that might consume vulnerable, externally laid eggs. The internal environment of the mother provides a stable, controlled sanctuary where the embryos can develop in relative safety, increasing their chances of survival. The number of offspring produced by a female cookie-cutter shark is relatively small, typically ranging from 6 to 12 pups per litter. This low fecundity is characteristic of many deep-sea species which often invest heavily in a smaller number of well-developed young rather than producing a large quantity of less developed offspring. Each pup, upon hatching, internally continues to develop within the mother's oviducts, growing larger and more robust before being born. The gestation period is unknown, but scientists believe it is likely extended, perhaps lasting many months, allowing for significant development of the pups before their entry into the vast, unforgiving ocean. When the pups are finally born, they emerge as miniature versions of the adults, fully formed and self-sufficient, ready to begin their independent lives in the deep. They are born at a relatively large size, typically around 14 to 15 centimeters in length. This larger size at birth is another crucial adaptation for deep-sea survival. A larger pup is better equipped to withstand the environmental challenges, to avoid predation, and to begin foraging for itself immediately. Imagine these tiny cigar-shaped sharks, each with its perfectly formed array of teeth and its nascent bioluminescent capabilities embarking on their solitary journey in the boundless darkness. The diet of these juvenile cookie-cutter sharks is not well understood, but scientists believe they likely begin by feeding on small crustaceans, cephalopods, and possibly smaller fish found in the deep. As they grow and mature, their predatory capabilities, particularly their specialized dentition and bioluminescent lure, will develop, allowing them to transition to the parasitic feeding strategy on larger prey that defines the adult Isistius brasiliensis. The development of their photophores, their ability to precisely control bioluminescence, and the full functional integrity of their unique jaw mechanism are all critical milestones in their growth towards becoming effective deep-sea surgeons. The slow growth rates and extended lifespans are also characteristic features of many deep-sea organisms, including the cookie-cutter shark. In the cold, energy-poor environment of the deep, metabolic processes are often slowed, leading to slower growth and later sexual maturity. Scientists believe that cookie-cutter sharks likely take several years to reach sexual maturity, contributing to their relatively low reproductive output. This life history strategy, investing in a few well-developed offspring over a long period, is a common adaptation to stable yet resource-limited deep-sea environments. The deep-sea void presents unique challenges for reproduction. The vastness of the habitat means that encounters between males and females can be rare. Species adapted to such environments often employ specific strategies to maximize reproductive success when these encounters do occur. While the specific courtship rituals or aggregation behaviors of cookie-cutter sharks are unknown, it is plausible that chemical cues or even subtle bioluminescent signals might play a role in attracting mates across the immense distances. The cycle of life for the cookie-cutter shark is a quiet, persistent affirmation of survival in one of Earth's most extreme habitats. From a tiny yolk-nourished embryo protected within its mother's body to a self-sufficient pup emerging into the vast darkness, and eventually to a mature adult perpetuating its lineage. Each stage is a testament to the finely tuned adaptations that allow this species to endure. It is a story of resilience, of subtle strategies, and of the profound mystery that shrouds the most fundamental processes of life in the deep. As we gently contemplate these unseen beginnings and continuations, we are reminded that even in the most desolate and challenging environments, the imperative to reproduce, to pass on life, remains a powerful driving force. The cookie-cutter shark, in its quiet, persistent way, ensures its place in the deep-sea ecosystem, perpetuating its lineage through a strategy that is as unique and enigmatic as its parasitic bite. Its cycle of life unfolding in the silent void is another whispered chapter in the endless dreaming story of our planet's oceans. The cookie-cutter's ecological role. From the profound unseen beginnings of its life cycle emerging into the vast silent void, we now shift our focus to the broader canvas of the ocean itself, contemplating the subtle yet pervasive ecological role of the cookie-cutter shark. Its influence, often unseen and rarely directly observed, ripples through the deep-sea ecosystem, a quiet force that shapes the lives and even the very forms of countless larger creatures. This is an influence not of dramatic kills and overt predation, but of chronic interaction, a persistent surgical sculpting of the marine world by a diminutive, enigmatic force. The primary ecological impact of Isistius brasiliensis stems directly from its unique parasitic feeding strategy. While it rarely, if ever, causes immediate mortality to its colossal hosts, each bite leaves a deep, open wound. Imagine the smooth, pristine skin of a blue whale suddenly marred by a perfectly circular crater several centimeters deep, exposing raw muscle and blubber to the vast microbial ocean. This is not merely a superficial scar, it is a breach in the host's natural defenses, an invitation for infection. In the ocean's warm, bacteria-laden surface, waters where many of these host animals spend a significant portion of their lives, such wounds become vulnerable entry points for pathogens. A bacterial infection, if left unchecked, can spread, causing localized necrosis, systemic illness, and potentially even sepsis, slowly weakening the host over time. Consider the energetic cost imposed upon the host. Healing an open wound requires a significant allocation of the host's metabolic resources. Energy that would otherwise be used for growth, reproduction, migration, or hunting must be diverted to tissue repair, immune response, and fighting off potential infections. For a large marine mammal or fish, which might already be expending immense energy on its daily activities, swimming vast distances, diving to extreme depths, or navigating complex social structures, these additional energetic demands can accumulate. A single bite might be a minor inconvenience, but many individuals bear dozens, even hundreds of cookie-cutter shark scars, indicating repeated encounters over their lifetime. This cumulative stress, this constant drain on their energy reserves, can subtly yet significantly impact their overall fitness, making them less robust, less resilient to other environmental stresses. The physical effects of these wounds can also manifest in subtle behavioral or physiological changes. A deep bite on a fin, for instance, could momentarily impair swimming efficiency, altering hydrodynamics and requiring more energy for propulsion. A wound near a vital sensory organ could temporarily affect its function. While these effects are generally not debilitating for a healthy adult, for a young, inexperienced animal, or an old, weakened one, even minor impairments could tip the balance, increasing its vulnerability to other predators or reducing its foraging success. The scars themselves, while healing, might also alter the flow of water over the animal's skin, potentially creating slight drag or affecting its sensory perception of its environment. Beyond the individual impact on hosts, the cookie-cutter shark plays a quiet yet consistent role in nutrient cycling within the deep-sea ecosystem. Each plug of flesh it removes represents a small yet regular transfer of biomass and energy from the highly productive upper layers of the ocean, where large pelagic animals forage down into the less productive deep-sea environment. While the individual contribution of a single bite is minuscule, the sheer number of cookie-cutter sharks and the frequency of their attacks mean that collectively they facilitate a continuous, albeit subtle, downward flux of organic material. This distributed input of nutrients derived from the surface helps to sustain the sparse food webs of the deep, providing a consistent energy source for the cookie-cutter shark itself, and indirectly for other deep-sea scavengers or detritivores that might consume the shed skin or tissue from its victims. The cookie-cutter shark's parasitic strategy also contributes to niche partitioning within the deep-sea environment. By specializing in taking small living tissue samples from colossal hosts, it avoids direct competition with other deep-sea predators. Most deep-sea sharks and fish either hunt smaller prey, scavenge on carcasses that sink from above, or are ambush predators of other mesopelagic organisms. The Isistius brasiliensis occupies a unique ecological space, one that allows it to tap into a vast, otherwise inaccessible food source without engaging in direct, energy-intensive competition. This specialization allows for greater biodiversity and more efficient utilization of resources across the vast ocean depths, a silent agreement among species to carve out their own paths to survival. While difficult to prove definitively, it is also plausible that the constant threat of cookie-cutter shark attacks could subtly influence the behavior and distribution of its hosts. Imagine a large marine mammal repeatedly bitten in a particular area or at a specific depth. Over time, it might learn to avoid those areas or depths, altering its migratory patterns or foraging behavior to minimize encounters. Such subtle behavioral shifts, if widespread across a population, could have cascading effects on the distribution of other species, on predator-prey dynamics, and even on nutrient transfer processes. This would represent a profound yet almost invisible ecological influence exerted by a creature so small. From a scientific perspective, the cookie-cutter shark's scars serve as a unique form of biological tagging. The presence and distribution of these distinctive circular wounds on various marine animals can provide invaluable data to researchers. By observing the patterns of scarring on whale populations, for instance, scientists can infer details about their migratory routes, their depth usage, and the areas where they are most likely to encounter cookie-cutter sharks. These scars act as silent witnesses recording the interactions between deep-sea and pelagic fauna, offering glimpses into the movements and lives of elusive species that are otherwise incredibly difficult to track and study. They are living maps etched onto the very bodies of the ocean's giants, revealing the unseen journeys and encounters of the deep. The overall impact on host populations is generally considered to be non-lethal, and thus not a primary factor in population regulation. However, for species already facing significant threats from human activities, such as entanglement in fishing gear, ship strikes, pollution, or climate change, the chronic stress and potential for infection from cookie-cutter shark bites could represent an additional cumulative burden. While not a direct cause of population decline, it could contribute to a reduction in overall fitness, making populations more vulnerable to other stresses. This is a subtle, indirect influence, yet one that deserves consideration in the complex web of conservation efforts. Ultimately, the ecological role of the cookie-cutter shark is a testament to the intricate interconnectedness of deep-sea ecosystems. It reminds us that even the most unassuming and rarely seen creatures can exert a significant, if understated, influence on the health, behavior, and dynamics of the entire marine environment. Its existence highlights the boundless ingenuity of evolution, which has sculpted a creature perfectly adapted to exploit a unique niche, shaping its world through a strategy of precision and persistence. The challenge of quantifying this unseen influence is immense. The deep ocean remains largely unexplored, and the elusive nature of Isistius brasiliensis makes direct observation of its ecological interactions incredibly rare. Much of our understanding is built upon inference, forensic evidence, and the meticulous piecing together of biological data. Yet the consistent presence of its signature scars, from the smallest deep-sea fish to the largest whales, speaks volumes. It whispers of a continuous silent interaction, a pervasive force that, despite its small size, holds a significant, albeit subtle, sway over the vast, dreaming waters of our planet. The cookie-cutter shark, in its quiet, persistent way, is a constant reminder that the deep sea is not a static void, but a dynamic living system forever being sculpted by the unseen influences of its most enigmatic inhabitants. Challenges in deep sea ichthyology. Having contemplated the subtle yet pervasive ecological influence of the cookie-cutter shark, our journey now turns to the human endeavor of understanding this enigmatic creature. We delve into the profound challenges faced by deep-sea ichthyologists, those dedicated scientists who pursue the phantom of Isistius brasiliensis. Through the vast, silent, and often hostile realm of the abyssal zone. Studying a creature that lives in perpetual darkness, migrates vertically across immense distances, and leaves only fleeting evidence of its presence, demands extraordinary patience, ingenuity, and resilience. The most fundamental challenge in pursuing the cookie-cutter shark is its elusive habitat itself. Imagine trying to study a species that lives in a realm of crushing pressure, frigid temperatures, and absolute darkness, often hundreds or thousands of meters below the surface. The very act of reaching these depths requires specialized, immensely complex, and extraordinarily expensive equipment, remotely operated vehicles or ROVs, human-occupied submersibles or HOVs, and robust deep-sea trawls. Each dive, each deployment is a logistical and financial undertaking of immense proportions, often lasting for hours or days, yet exploring only a minuscule fraction of the vast ocean volume. The sheer scale of the cookie-cutter shark's habitat, spanning across the tropical and temperate pelagic zones of all major oceans, makes comprehensive sampling and observation a monumental task. Direct observation of Isistius brasiliensis in its natural environment is exceptionally rare, almost a mythical event for deep-sea biologists. Unlike shallow water sharks that can be observed and filmed with relative ease, the cookie-cutter shark actively avoids light and human presence. Even when deep-sea cameras are deployed, the chances of encountering a cookie-cutter shark are slim, and the probability of witnessing its unique predatory strike is infinitesimally small. The few recorded observations have often been incidental, captured by cameras focused on other deep-sea phenomena, offering fleeting glimpses of its cigar-shaped form drifting through the gloom. These brief visual encounters, while invaluable, provide only fragments of its life story, leaving vast gaps in our understanding of its behavior, social interactions, and daily routines. Collecting specimens for study presents its own unique set of difficulties. Deep-sea trawling, the primary method for collecting deep-sea fish, involves dragging large nets through the water column. While cookie-cutter sharks are occasionally caught in these trawls, the process itself can be damaging. The extreme pressure changes as the net is brought to the surface can cause physiological trauma to deep-sea organisms, often resulting in death or severe injury. Delicate structures such as photophores can be damaged, and behavioral observations are impossible on deceased or traumatized specimens. Furthermore, trawling is inherently indiscriminate, collecting a wide array of species, making targeted collection of the elusive cookie-cutter shark a matter of chance rather than precision. Once a specimen is successfully retrieved, its study still presents challenges. Preserved specimens, while invaluable for anatomical and genetic analysis, cannot reveal the dynamic aspects of its biology, such as the precise modulation of its bioluminescence, the strength and mechanics of its bite in action, or its vertical migration patterns. Scientists meticulously examine the dentition, the photophores, the liver composition, and the stomach contents of captured sharks, piecing together clues about its diet, its adaptations, and its life history. Each preserved specimen becomes a silent witness, offering fragments of a larger, unseen narrative. Understanding the cookie-cutter shark's daily vertical migration is particularly arduous. Tagging studies, a common method for tracking marine animals, are incredibly difficult to implement for this species. Its small size, deep-dwelling habits, and elusive nature make the attachment of tracking devices a formidable challenge. The tags themselves must be robust enough to withstand extreme pressures, and cold, yet small enough not to impede the shark's movement. Retrieving data from these tags, often requiring the shark to surface or pass near a receiver, adds another layer of complexity. Scientists often infer its migratory patterns from broader observations of the deep scattering layer. The dense aggregations of vertically migrating organisms that include the cookie-cutter shark's prey, rather than from direct tracking of individual sharks. The very nature of its parasitic feeding strategy, while fascinating, also complicates its study. Since it takes only a small plug of flesh and leaves its host alive, direct observation of predation events is rare. Scientists rely heavily on the forensic evidence left behind the perfectly circular wounds on the bodies of whales, dolphins, tuna, and even other sharks. These scars are ubiquitous, a global testament to the cookie-cutter shark's presence, but they tell only part of the story. They indicate that an attack occurred, but not how, often, when, exactly, or why a particular individual was targeted. The precise mechanics of the bite and the role of suction are still largely theoretical, based on anatomical inference rather than direct visual confirmation. Furthermore, the cookie-cutter shark's interaction with man-made objects while providing compelling evidence of its presence also poses its own set of research questions. Why does it attack submarines and cables? Is it purely mistaken identity, or are there other factors such as electromagnetic fields at play? These questions require interdisciplinary approaches combining marine biology with engineering and physics to fully unravel the complex sensory cues that might trigger these non-biological attacks. The scientific pursuit of the cookie-cutter shark is therefore a meticulous, patient endeavor built upon indirect evidence inference and the slow accumulation of data from diverse sources. It is a puzzle pieced together from countless fragments: the morphology of its teeth, the chemistry of its bioluminescence, the composition of its liver, the scars on its victims, and the occasional fleeting glimpse from a deep-sea camera. Each piece, no matter how small, contributes to a slowly emerging picture of this enigmatic deep-sea phantom. Despite these immense challenges, the dedication of deep-sea ichthyologists continues to push the boundaries of our knowledge. Advances in deep-sea technology, such as more sophisticated ROVs with advanced imaging capabilities, autonomous underwater vehicles, AUVs that can survey vast areas, and improved tagging technologies, offer new hope for unlocking the remaining mysteries of Isistius brasiliensis. The development of DNA analysis techniques also allows for the identification of shark species from tissue samples, potentially even from the remnants of tissue left in bite marks, offering a non-invasive way to confirm its presence and activity. The pursuit of the cookie-cutter shark is more than just the study of a single species. It is a microcosm of the broader challenges and triumphs of deep-sea exploration. It reminds us that our planet's largest habitat, the deep ocean, remains largely unknown, a vast frontier filled with creatures that defy our terrestrial expectations. The phantom-like nature of the cookie-cutter shark, its ability to exist just beyond the reach of our direct observation, only enhances its allure, compelling scientists to continue their patient, methodical quest for understanding. As we slowly drift through the contemplation of these scientific endeavors, we are reminded of the profound dedication required to unravel the secrets of the deep. The cookie-cutter shark, in its quiet, persistent way, remains a symbol of the ocean's enduring mystery, a creature that continues to challenge, to inspire, and to subtly guide our exploration into the boundless, dreaming waters of our planet. The pursuit of this phantom is a testament to human curiosity, a quiet, continuous quest for knowledge in the face of immense, unwavering depths. Future explorations of Isistius brasiliensis. Despite the patient accumulation of knowledge, the meticulous piecing together of anatomical clues, and the profound insights gleaned from its unique predatory strategy, the Cookiecutter Shark. Isistius brasiliensis remains in many ways an enduring riddle. Its life unfolds largely beyond the reach of our direct senses, a phantom in the perpetual night, a creature of whispers and fleeting glimpses. The vastness of its habitat, the extreme conditions it endures, and its elusive nature combine to shroud much of its existence in mystery, beckoning future generations of deep-sea ichthyologists to continue their slow, deliberate pursuit. One of the most compelling frontiers for future exploration lies in the realm of direct observation. While current deep-sea submersibles and remotely operated vehicles, or ROVs, have provided invaluable, albeit rare, glimpses, their limitations are pronounced. Imagine a future where autonomous underwater vehicles, AUVs, equipped with advanced low-light cameras and sophisticated sensory arrays, could patrol the mesopelagic and bathypelagic zones for extended periods, perhaps for weeks or even months at a time. These robotic sentinels, silent and unobtrusive, could patiently drift through the Cookiecutter Shark's domain, increasing the probability of witnessing its elusive behaviors. Scientists envision AUVs capable of learning its preferred depths and migratory patterns, adjusting their own patrols to maximize encounters, slowly gathering a living tapestry of its movements and interactions in real time. Further advancements in tagging technology also hold immense promise. Current tracking devices, while powerful for larger, shallower-dwelling sharks, face significant hurdles when applied to the diminutive deep-sea cookiecutter. Future tags could be miniaturized to an even greater extent, becoming almost imperceptible on the shark's small body, while simultaneously engineered to withstand the crushing pressures of thousands of meters. These next-generation tags might incorporate sophisticated sensors to record not only depth and temperature, but also the precise modulation of its bioluminescent photophores, the subtle electrical fields it detects, and even the minute vibrations of its unique bite mechanics. Imagine retrieving a tag that has recorded the exact moment of a parasitic strike, revealing the precise sequence of suction grip, and rotational cut, a silent film of its enigmatic attack played out in the deep. A profound area of ongoing mystery revolves around the Cookiecutter Shark's reproduction. While we understand its ovoviviparous strategy and the general characteristics of its pups, the intimate details of its courtship, mating, and gestation remain entirely unknown. How do males and females dispersed across vast ocean volumes find each other in the absolute darkness? Are there specific chemical cues, pheromones released into the water acting as silent invitations? Do subtle bioluminescent displays play a role in attracting mates, perhaps a different pattern or intensity than those used for predation? Future genetic studies analyzing DNA from populations across different ocean basins could reveal insights into its reproductive isolation, population structure, and genetic flow, slowly painting a picture of its global breeding patterns. The possibility of ever directly observing the birth of a cookiecutter pup in the wild, a momentous event in the deep-sea void, remains a distant yet captivating scientific dream. The early life stages and development or ontogeny of the cookiecutter shark also present a significant knowledge gap. What do the newly born pups at 14 to 15 centimeters feed on before they are large enough to take on giants? Do they possess fully functional photophores and biting mechanisms from birth? Or do these crucial adaptations develop over time? Understanding the progression of its feeding strategy from smaller prey to its iconic parasitic bites would provide invaluable insights into its ecological niche and its maturation process. Controlled laboratory environments, though challenging to replicate deep-sea conditions, could potentially allow for the study of juvenile feeding behaviors, shedding light on this crucial phase of its life cycle. Beyond its biology, future explorations will undoubtedly delve deeper into the Cookiecutter shark's broader ecological impact. While we acknowledge its role in wounding large marine animals, the long-term consequences for host health and population dynamics are still largely theoretical. Scientists hope to conduct more extensive studies on scarred individuals, tracking their health over time, assessing rates of infection, and quantifying the energetic costs of wound healing. This would require long-term monitoring programs, perhaps utilizing advanced imaging techniques to regularly assess the healing process of specific scars on identified individuals, slowly building a comprehensive understanding of the cumulative burden these bites impose. The interaction of the Cookiecutter shark with human technology also continues to be a compelling area of research. As humanity deploys more sophisticated and sensitive equipment into the deep, from advanced oceanographic sensors to ever-growing networks of submarine cables, understanding the precise triggers for these scars on steel becomes increasingly important. Future studies might involve deploying specialized bait packages or acoustic lures near deep-sea cameras designed to mimic the electromagnetic fields or acoustic signatures of human technology, allowing scientists to observe the shark's investigative and predatory responses to these artificial stimuli in a controlled yet natural environment. This could lead to the development of deterrent technologies safeguarding vital infrastructure from the silent surgical attacks of this deep-sea phantom. The very physiology of the Cookiecutter shark, its internal workings, continues to hold unanswered questions. How does its specialized liver maintain buoyancy across such immense pressure gradients? What are the precise neurological and hormonal mechanisms that control its intricate bioluminescent displays, allowing for such fine-tuned modulation of light intensity and pattern? Detailed physiological studies, perhaps utilizing advanced non-invasive imaging techniques on live specimens, could unlock these secrets, revealing the intricate adaptations that allow it to thrive in such an extreme environment. Ultimately, the enduring riddle of Isistius brasiliensis is a testament to the vast, unexplored wonders of our planet's oceans. Each question answered seems to reveal a cascade of new inquiries, drawing us deeper into the mysteries of life in the abyssal zone. The pursuit of this phantom is a continuous journey, a slow, patient unveiling of nature's profound ingenuity. It reminds us that even with all our technological advancements, much of the deep ocean remains a realm of silent secrets, a vast, dreaming expanse where creatures like the Cookiecutter shark drift forever, hinting at the boundless, beautiful complexities of life on Earth. And the quest to understand it, to gently illuminate its hidden world, continues to beckon a quiet call into the profound depths. And so, as we drift away from the silent, enigmatic world of the Cookiecutter shark, a creature of hidden depths and precise, unseen actions, allow your own conscious thoughts to begin their slow, gentle descent. Just as the deep ocean holds its profound mysteries in its dark, quiet embrace, inviting us to contemplate the unseen, so too does the realm of sleep now await to enfold your mind in its own unique, unfolding dreamscapes. The subtle, persistent currents of the deep carry their timeless secrets, much like the gentle, rhythmic tides of slumber, carry you towards a profound rest where new forms and silent stories await beyond the edge of waking. Release any lingering thoughts, letting them float away like bioluminescent specks, fading into the vastness, dissolving into the pervasive calm. Feel the quietude of the abyssal zone settle around you, a deep, comforting stillness that gently draws you downwards. May your sleep be as profound and undisturbed as the ocean's deepest, most mysterious waters. And may your dreams be as vivid and boundless as the unseen life that thrives within them. Let the gentle, unseen currents of the deep carry your mind into slumber, where perfect peace and silent exploration await your weary spirit. Sleep well. Goodbye, and see you again.